Okay, to find the exact value of these trig functions, we're going to need our unit circle. So in each case, I'm going to refer back to that unit circle. So our unit circle for pi over 6, it's asking for sine of pi over 6. And sine of pi over 6 is going to be cosine comma sine 1/2. You change the width on this. So this is equal to 1 over 2. Second one, letter B, cosine of 5 pi over 4. Again, go to your unit circle, and you go to 5 pi over 4. And cosine is the first number in the ordered pair, so it's negative root 2 over 2. Next, we're looking for tangent of 5 pi over 3. So we go to 5 pi over 3, and tangent is sine over cosine. So it's negative root 3 over 2 divided by 1/2. Negative root 3 over 2 divided by 1/2. The 2's end up canceling out when you multiply by the reciprocal. And this becomes negative root 3 over 1, which is just negative root 3. Sine of 3 pi over 2 for letter D. So 3 pi over 2 is down here, and cosine comma sine. That means the sine is going to be negative 1. So this is negative 1. Letter E, cosine of pi. Again, pi is here, and cosine is the first number in the ordered pair, so that's going to be negative 1. Tangent of pi over 2. So you go to pi over 2. Tangent is sine over cosine. So it's 1 over 0. And 1 over 0 is undefined. Tangent of negative 7 pi over 4. So negative 7 pi over 4 does not show up in the unit circle. So I'm going to take negative 7 pi over 4 and add 2 pi to that to find something within the unit circle. So this is really negative 7 pi over 4 plus 8 pi over 4. Because 8 pi over 4, you need the common denominator, is 2 pi. So this is going to become, actually, they're asking for tangent of pi over 4. So again, you are going to your unit circle. You're going to find pi over 4. And tangent is sine over cosine. So it's root 2 over 2 divided by root 2 over 2. And that's equal to 1. Letter H. Cosine of negative 4 pi over 3. Again, negative 4 pi over 3 is not on the unit circle. It's not where it appears for our unit circle. This is a coterminal angle. So again, we're going to be adding 2 pi. I have no idea what that pen just did. Negative 4 pi over 3 plus denominator of 3 times 2 pi is 6 pi over 3. So what it's really asking you to find is cosine of negative 4 plus 6, which is 2 pi over 3. So we're going to run over to our unit circle. And we're going to go to 2 pi over 3, and cosine of 2 pi over 3 is the negative 1/2. Okay, letter I is not on this page. Next page. Letter I, negative 11 pi over 6. Same situation as the last two. Negative 11 pi over 6 isn't on the unit circle. So we're going to be finding a coterminal angle for that by adding 2 pi. So negative 11 pi over 6. This has to have a denominator of 6. 6 times 2 pi is 12 pi over 6. So what we're really asking for here is a sine of pi over 6. This should be one you have memorized at this point. But again, go to pi over 6. Cosine kind of sine means that's going to be equal to 1/2. Letter J, sine of pi over 4. Pi over 4, cosine comma sine is going to make this value here, root 2 over this ratio, root 2 over 2. Cosine of 5 pi over 6. Cosine comma sine is going to make this negative root 3 over 2. Whoops, where do we go here? Negative root 3 over 2. 7 pi over 6. Again, go to your unit circle. It's here, and it's asking for tangent. So it's sine over cosine. So it's negative 1/2 over negative root 3 over 2. You're going to have to simplify this. Negative 1/2 over negative root 3 over 2. When you multiply by the reciprocal, you're going to have positive, because negative divided by negative is positive. 1 over root 3. And you can't leave it like that because it's got a radical in the denominator. So you rationalize it, and this becomes root 3 over 3. Letter M, secant. So we could negative pi 5 pi over 4 again is not on that unit circle. So we're going to take negative 5 pi over 4 and add 2 pi, which is going to be 8 pi over 4. So we're finding secant, I have no idea why that keeps doing that, of 3 pi over 4. Now, secant's not kind of really on the unit circle. It's the reciprocal function for cosine. So this is really 1 over cosine of 3 pi over 4. So when you look up 3 pi over 4 in the unit circle, and you find cosine for 3 pi over 4, it's negative root 2 over 2. So this is really 1 over negative root 2 over 2. And when you get that, and do the reciprocal of that, that's negative 2 over, whoops, messed that up, negative 2 over root 2, which needs to be simplified. So you multiply by root 2 over root 2, and we get negative 2 root 2 over 2, which simplifies to give you negative root 2. Let me make a little section separating this. Cotangent, again, not on the unit circle, so this is going to be 1 over the tangent, 1 divided by the tangent of 5 pi over 6. So when you go to your unit circle for 5 pi over 6, well, you can do a couple different things here. You're going to have to find, tangent is normally sine over cosine. So cotangent is cosine over sine. So you can actually, you don't have to make tangent first, because you can just do the negative root 3 over 2 divided by 1/2. Which is going to be equal to negative root 3 or negative root 3 over 1. Okay, because again, cotangent we can do as cosine over sine instead of sine over cosine for tangent. And it's just an easier way of doing the problem. Cosecant of 4 pi over 3. Again, cosecant is the reciprocal of sine. So again, you can do this a number of different ways, but one way is 1 over sine of 4 pi over 3. Go to 4 pi over 3 on the unit circle, and you're looking at sine of 4 pi over 3, which is negative root 3 over 2. So again, it's 1 divided by negative root 3. When you multiply that by the reciprocal, it's going to be 2 over negative root 3. You have to rationalize that, and this becomes negative 2 root 3 over 3. And the last one in this section, secant of pi, again, is really the same as 1 over the tangent, cosine is the reciprocal of secant. So 1 over the cosine of pi. You go to pi on the unit circle, and cosine is negative 1. So this is going to be 1 over negative 1, which is just negative 1. Okay, 28. What you need to look at is 28 and 29 here together. I know this problem is going to be tan inverse, because what you are doing here is it's inverse tan exists between negative pi over 2 and pi over 2. I know this problem is, again, between negative pi over 2 and pi over 2 is going to be sine inverse. How do I know the difference between these? Well, I know sine is going to be stop at endpoints, and tangent is going to be approaching asymptotes, because again, when you find the inverse of something, you're switching your x and your y values. So your asymptotes that were vertical asymptotes at negative pi over 2 and 3 pi over 2 for tangent become horizontal asymptotes at pi over 2 and negative pi over 2. We know that for cosine inverse, that exists between 0 and pi. So that should help us then do our properties above. So the domain, again, of sine is between -1 and 1. And the range is between negative pi over 2 and pi over 2. Again, just check your graph below. Domain, remember, set of all x values. The range is a set of all y values. For cosine, again, that's bounded both ways here. So cosine inverse is between -1 and 1. And again, cosine inverse exists between 0 and pi. And again, go back to your cosine. Again, x values between -1 and 1, y values between 0 and pi. And finally, tangent is right here. So it exists for all real numbers. So -infinity, infinity. So every x value could be an x value on the inverse tan function. And the y values are approaching, but not hitting, negative pi over 2, pi over 2.